Hello friends, in the last lecture we had seen certain problems pertaining to normal form of the line and intercept form of the line. Going further on the same topic of straight lines, today we shall see general equation of line and its various form, and we will try to depict the formula to calculate slope as well as x-intercept and y-intercept of a straight line in terms of the coefficient of x and y. So in that sense, the first case which we are going to study today is slope intercept form. Slope intercept form. In case suppose we are provided the equation of the line as ax plus by plus c is equal to 0, and we take b is not equal to 0. Let this equation ax plus by plus c is equal to 0 be the equation of our line with the condition that b is not equal to 0. Then I will try to formulate the equation, the standard equation of line in our slope intercept form. We already know that the slope intercept form of line is y equal to mx plus c. So I will try to formulate this standard equation of the line provided to us in this form, slope intercept form, and then based upon the formulation we will compare the coefficients of x and y as well as constant and try to find out what's the formula we shall get to calculate the slope as well as the intercept, different intercepts like x-intercept and y-intercept of the standard form of our line. So going further, what I'll do, I'll convert a standard form of the line, that is ax plus by plus c is equal to 0 in the slope intercept form. And for that, if I'll see my slope intercept form, I can see that my y coordinate is on the left hand side of the equal to sign, while my x coordinate and constant are on the right hand side. So I will try to formulate the standard equation of the line in the same format, and what we'll do, we'll first take x, the terms containing x as well as its coefficient and constant on the other side of the equal to sign. So we'll keep by is equal to minus of ax minus c, and further what we'll do, since we had taken b is not equal to 0, we will divide both the side by b. So dividing both the side by b, I'll get minus of ax minus c whole upon b. Further, I can write this, let me put the implies sign. So this implies b and b get cancelled out from the numerator as well as denominator, so we would be left with only y at the left hand side, and on the right hand side I can write minus of a upon b of x minus c upon b. Let me put this equation as number 1. Now we had seen that this standard form of the line has been formulated in terms of y is equal to mx plus c. So y is equal to mx plus c. Comparing these two equations, y equal to mx plus c and y equal to minus of a upon b of x minus c upon b, I can say that m is equal to minus of a by b. Friends, here first we are comparing the term with variable x of the equation number 1 with the term with variable x of our slope intercept form. So I can see that mx, and over here I can see that minus a upon b of x. So by comparing these two equations, I'll get m is equal to minus a by b. And similarly, by comparing the constant term for the equation number 1 which we had obtained over here and slope intercept form, I can see that the small c in the slope intercept form can be equated with the same constant of our equation 1, which over here is minus c by b. So I can write that constant small c is equal to minus of capital C by capital B. Hence, from this further I can say that now if we compare that slope of our slope intercept form is equal to minus a by b and constant is equal to minus capital C by b. Now in the standard equation of the line which we had taken in the starting, which is ax plus by plus c equal to 0, I can say that a is the coefficient of x, b is the coefficient of y, and c as the constant. So if I'll depict my slope which we had obtained over here, equation of slope m is equal to minus a by b, but a is the coefficient of x. So instead of a, I can write that minus of coefficient of x whole upon coefficient of y. Since we had seen that a over here depicts the coefficient of x and b over here depicts the coefficient of y. So instead of minus a upon b, I can write my slope m is equal to minus of coefficient of x upon coefficient of y. Similarly, I can see that capital C upon capital minus of capital C upon capital B is compared to the constant of slope intercept form. So small c is equal to minus c upon b. Here capital C is the constant term of our standard equation of the line and b is the coefficient of y. So I'll write them in the same way, and small c is equal to minus of constant term whole upon b as the coefficient of y. So I'll write b as coefficient of, hence from this we'll get to know two formulas provided the standard equation of the line, and they are slope of that line is equal to minus of coefficient of x upon coefficient of y. Similarly, we got to know c. Now over c over here was y-intercept of the x-axis. Over here in slope intercept form, in the initial lecture we have seen that c is the y-intercept of the axis. Hence c is the y-intercept, and y-intercept of the line is equal to constant term upon coefficient of y. So these are the two formulas which we formulated with the help of this derivation. So I can write that slope, where m is the slope of line, is equal to minus of coefficient of x upon coefficient of y, and c is the intercept on y-axis or y-intercept. Hence y-intercept of the line is equal to minus of constant term of the line upon coefficient of y. So we had derived the two equations, one for the slope of calculation for the slope of the line and other for the y-intercept of the line in terms of the coefficient of x, coefficient of y, and constant term which are provided to us in the standard equation of the line. So going further, we shall now try to derive x-intercept form and y-intercept form with the help of the standard equation of the line provided to us and comparing it with the intercept form of the line. So this was the first derivation which we saw. We shall now further our case to the second derivation with the help of intercept form. So let me put this as intercept form. Now friends, we already know that intercept form of the equation of line is x upon small a plus y upon small b is equal to 1, where small a is the x-intercept which our line makes and B is the y-intercept which our line makes with the y-axis. So A and B are x-intercept and y-intercept which our line makes with x-axis and y-axis respectively. Now let's say we are provided an equation of the line which is ax plus by plus c is equal to 0. Now I need to calculate the x-intercept as well as the y-intercept of this equation of the line ax plus by plus c equal to 0. Then we will now try to derive the formula how we can calculate with the help of the coefficient as well as the constant term to know what is the x-intercept and y-intercept which this line makes with the respective x-axis and y-axis. Now I can see my intercept form of the line are x upon some constant term which over here is x-intercept and y upon some constant term which over here is y-intercept is equal to 1. So on the right hand side in the intercept form we see that it is 1 over here, and on the left hand side I have x upon something plus y upon something. So I will try to formulate my standard equation of the line which is ax plus by plus c equal to 0 in the intercept form, wherein I'll try to first put on the right hand side as 1 and then on the left hand side I'll try to put x upon something plus y upon something, and then we will compare this equation of the line with our standard intercept form of the line. So first step is to make right hand side as 1. So what I'll do, it implies ax plus by. I'll take this constant term on the right hand side. So plus c becomes minus of c. Now I will divide on both the side by c. I'll divide both LHS and RHS by c. So I'll get ax plus by whole upon c is equal to minus of c upon c. So this is dividing both the side by c. So over here now I can see that I am getting, if c and c get cancelled out, I'll get over here is minus c. So what I'll do, instead of dividing by c, I'll put it minus c on both the sides. So dividing both the side by minus c, now I'll get c, minus c and minus c get cancelled out on the right hand side and I'll get 1. So my equation now becomes ax plus by whole upon minus c is equal to 1. Now segregating the denominator, I'll get minus of a by c of x minus of b by c of y is equal to 1. Now further, if I compare this standard equation of the line with my intercept form, I can see that in the numerator I am having x and y, and in the denominator I'll have some constant term. So I'll do the same over here. I'll put x in the numerator and I'll take a in the denominator. So this equation becomes c upon a with a minus sign plus I'll take b in the denominator in the same way as I did for the a. It becomes y upon minus of c upon b is equal to 1. I'll name this equation as number 1. Now comparing first equation with our intercept form, I can see that it is in the form of x upon a plus y upon b equal to 1. Over here I'll get x upon minus of c upon a plus y upon minus of c upon b is equal to 1. So if I'll compare our equation number 1 with the intercept form, I can say that small a is equal to minus of capital C upon capital A and small b is equal to minus of capital C upon b. So by comparing equation number 1 and intercept form, I will get a is equal to minus of c upon a and small b is equal to minus of capital C upon capital B. Now as per the standard equation of the line ax plus by plus c, I can say that c is the constant term and a is the coefficient of x, and c is the constant term and b is the coefficient of y. Moreover, for small a and small b, I know that small a is the x-intercept and small b is the y-intercept. So I'll write the same definition in the next line. A, which is the x-intercept, x-intercept of the line is equal to minus c by a. So minus c is constant term. So minus of constant term whole upon a is the coefficient of x. So I'll write coefficient of x. So x-intercept of the line is equal to minus constant term upon coefficient of x. Similarly, for small b is equal to minus capital C upon capital B, I know that small b is the y-intercept. So I'll write over here y-intercept of the line is equal to minus C as minus of constant term. So that is equal to minus of constant term whole upon coefficient of y. So these are the formulas to calculate the x-intercept and y-intercept of the line in terms of constant term and coefficient of x and coefficient of y. Now, if I'll see y-intercept of line is equal to minus of constant term of coefficient of y. In second case, we had calculated y-intercept as this, and if you compare in the first case also, you'll get constant term upon coefficient of y is the small c. So minus of constant term is upon coefficient of y and minus of constant term upon coefficient of y. I'll get both the y-intercept of the line as same in the equation. So from this I can say that this formula is consistent for both the cases.